So this one like is the metallization room. Like here, like there are all the metal deposition tools. There are actually 4 different metallization. So this one is Plastis 4. This is a metal evaporation tool. So this is for evaporation of the most common metal, including titanium, gold, and for example palladium. And this one is very similar to this other evaporation tool. The only difference is in the metals available, because there are some slight difference. Only one of these evaporator has platinum, whereas only the other one has palladium, and the same thing applies to, for example, molybdenum or some very often used metal. This one is Plastis 3. This one is a sputtering tool, and it's normally used for sputtering of, for example, tungsten, or sometimes even some dielectric like vanadium and tantalum oxides. And then if we go over here, this one is the newest tool that has been bought between the metal deposition tool, and this one is Plastis 6, that is used for the deposition of superconducting material. Then if we go over to the corner of the room, there is actually quite an old piece of equipment that is the modified evaporator, and is used for the deposition of metals that are not present in any of the other metal deposition tools. And typically it is indium for flip chip bonding, or silver or chromium. Okay, so like before we start, like let's have like a quick run through like what all the components like of these machines, and especially like what are like the do's and don'ts, and like what is what we can operate and what actually we must not touch. So like here, like there's the main control unit. So like most of the operations are actually done by controlling everything through the computer here. And also through this panel here. Everything else, like in the main control unit, is normally not touched. So like for example, this button is only used in case of emergency, and also these buttons are normally not used, and they must be used only by technical staff. This controller here is to control where the electron beam hits the metal, like in the crucible. It's a sort of joystick, like if you may, and also it's not for use by general users. As we go through here, we see the log chamber and the main chamber here. So like the main chamber is the one like where the crucible is, and that's the one where the electron beam is generated and to melt the metal that then evaporates through the log chamber where there is our sample upside down that is going to be deposited with metal. This is a cryo pump, this one that you see here. So it's a high vacuum pump that will pump the log chamber. So these are the electronics, and these are actually like the gauges. So leave this part alone, like don't come close to this area here, because there's no need to, only the technical stuff will. And here actually like there's an earthing rod. Again, you won't need to use these because this is used only by the technical staff. Whenever for maintenance they have to open the main chamber, and they won't like to put the main chamber to ground before doing any operation to be touched. So the only thing that as a general user one needs to do is actually open and close the load log chamber, load the sample in, take the sample out, turn on the power supply both with this key and by pressing the on button, and one will hear the power supply actually coming on. And then once the metal deposition is finished, one has to turn to do the same things in reverse order. So to hit the off button and to turn off the key. And then everything else is just computer controlled, so there's no need to touch or operate anything else. And in case the machine gives an error or you are in need of assistance, just contact a member of technical staff and they will help you. Okay, so this is the Placis 4. This is another metal evaporator. It's very similar to the Placis 2. It's mainly newer. There are only a few minor differences between the Placis 2 and the Placis 4, but the main operation mode and the way to use it is very similar. Again, as a general user, what you will need to do, it will be just like to load your sample in through this lock chamber and to take your sample out. You don't need to touch any of the vacuum pumps, connectors, any of the electronics that you see either here or here. Just as the Placis 2, there is also a small joystick to control where the electron beam is inside the chamber. This is again not for use by the general users. And here there's two indicators of atmospheric pressure. This one has an indicator for the lock or for the chamber, but the chamber is to be opened only by technical staff. So normally you should see only this one lighting up during normal operation. This one is the emergency stop button. And again, these two buttons, they should normally be left on. You should not turn them on yourself. Again, they're only for use by technical staff. The only small difference between like this machine and the Placis 2 is that one doesn't need to turn off turn on the voltage supply. So you don't need to touch anything on this panel here. The only thing you need to do is to log in here using your credentials, your username and your password, and then select a recipe and run an evaporation after you've loaded your sample. Again, another important thing, even if you book the machine and the machine is available on the JWNC website and there's no fault report appearing, if you see these notes on any of the Placis, it could be on Placis 2 or it could be on Placis 4, please do not use the machine, because it means that the technical staff is doing some maintenance on the metal evaporator. After the overview of all the metal evaporation tool, today's training will be on this particular metal evaporator Placis 2. So today we're going to do some metal evaporation on a sample using this piece of equipment, which is called Placis 2. It's one of the four actually metal evaporators in this room. So in order to do these, we're going to have like to load our sample on a special holder that is fitted like for this machine. Then we're going to have like to vent the chamber here. This is the load lock chamber where we're actually going to load our sample, and that's where the deposition is going to take place. And there is a computer interface that we are going to use. So if we go over like to the cabinet and this is where we do the loading of our samples before actually doing the Placis. So like I have like my sample ready for metal deposition prepared here, and And these, depending on the kind of metal evaporation and depending on the type of metallization that I want to do, this sample would have undergone several processes, such as plasma oxygen ashing or hydrochloric acid dip, or for example, in case I have to make ohmic contact, I have to remove the native oxide from the surface of the sample. So right after I've done like the oxygen ashing and the hydrochloric acid dip, my sample is ready to be mounted. There are like some set of wafer and sample holders here, like in this set of drawers. There's for all the 3 metal evaporators in this room. I need to get the holders that are in the Plastis 2 drawers, and this is the holder that I'm going to use. There are several holders. There are in total 4 holders depending on the kind of sample that I want to use. And I also need to get this holder here, which is the screen that is going to hold up the holder when I load it in the load lock, as it will become more clearer later. The other box that I need to get is the box of Plastis 2 clamps and screws, where I'm gonna find some clamps and screws, as I said, like to hold my sample down on the holder. So normally, the first thing one does is, after I decide where to place the sample on the holder, a common location is always on the center. And so after deciding where to put more or less my sample on the holder, then I start to put the screws and the clamp down in the 2 holes that I decided to use. And at the beginning I don't put them down all the way, but I put them down just loosely. Ideally, it's always good to use at least 2 screws for each sample in order to make sure that the sample is kept horizontal during the deposition. Because, for example, if I'm trying to make liftoff of the deposited metal, if the sample is at an angle during the deposition, that can result in problems during the liftoff process. So like once the clamps and the screw are loosely placed on the holder, then I place my sample in the center of the holder. I can deposit multiple samples at the same time if they all need like the same kind of metal evaporation. In that case, I would just place more screws and clamps down. Some holders, like some clamps, like they have like different shapes. Like some of them like have these shapes here, and so like they are slightly wedged. Some others are not. At the moment, like I'm using the ones that are not wedged, but they have like this shape, and these are the ones that is easier like to put down on this kind of sample, because they just keep horizontal during the deposition. Once I put my sample right there in the center, then I can lift the clamp slightly and just to cover slightly until it covers slightly the edge of the sample. And this is the reason why I didn't tighten the screw all the way, but I left it quite loose. And once the clamp is in position, actually I can place the screwdriver on top of the screw, and very slowly and very delicately I can, and trying to make sure that I keep the clamp in place, that the clamp doesn't move, I put the clamp in place in order to make sure that if I want to use just one clamp, as it might be requested by the pattern that I have on my sample. Maybe like I have a type of pattern on my sample that only that occupies most of the space, then if I can only use one clamp to make sure that the sample is horizontal, I need to put the clamp at least 2 millimeters inside the sample. So I need to make sure that there is always a space of 2 millimeter that is free of any pattern whenever I pattern my sample. And then the other thing, I don't want to the other thing is, the other thing is that I don't want to over tighten the screws, and as soon as there is some resistance from the screw against tightening, then I just want to stop. Otherwise, the sample might break. So once I did this on one side, I can actually do the same thing on the other side of the sample. That is, if the sample has enough space to allow for 2 clamps. So I put down the screwdriver, and while holding the sample down, I just okay, so now like my sample is actually ready like for metal deposition. And one good thing to do right before actually going and load the sample in the load lock is to check with the nitrogen gun if the sample is actually steadied in place. So if I give a good blow of nitrogen with the nitrogen gun and I see that the sample doesn't move, that means that probably is not gonna move during the metal evaporation. So once the sample it is in place, I need to place the sample holder onto this screen here. In order to do that, I have to put down this sort of screen this way, and then I need to make sure that on the other side the 3 notches that I find on the wafer on the screen are actually aligned with the notches in the sample holder, and this is so that the sample holder is kept, cannot freely rotate inside the screen. Now we're actually ready like to load these in the load lock of the Plasys 2 machine. So for now I'm gonna leave this here because we actually have to vent the chamber. So if we go over to the Plasys 2 machine, before the load lock vent is actually highlighted, I need to log in as a user. So once I am an authorized user, I will be given an account to use this machine. So I scroll down until I find my username. I type in my password, and right now the current user here is highlighted, and if I click on the current user, I just see my remaining quota of metals in this machine. So there are 8 metals that can be deposited between aluminum, germanium, gold, molybdenum, nichrome, nickel, platinum and titanium, and each user has an initial budget of 1 micron. After using up that micron, the technical staff has to be contacted in order to replenish the quota. So once I check that I have enough metal budget available like for my deposition, then I can go on and start venting the chamber. So before, this load lock vent that was highlighted can now be selected. So if I select load lock vent, I hear a noise, and here on the diagram I can see that this valve has been opened and the pressure of the load lock starts going up from the base pressure of around 10 to the minus 6. So right now I have to wait for the load lock to vent to atmosphere, And when that will happen, there's also a light that will turn on the right hand side of the machine. This light will come on once the load lock has reached atmosphere. In the meanwhile, one thing that I can do while the machine vents is actually select the process that I want to run. So I normally click on Run Process, and I can actually browse between a range of existing recipes that allow to do metal evaporation. So after clicking on Browse and then like clicking on Evap, on the right hand side of the screen I see the number of metals that I can use. If I select any metal, for example titanium, there will be, yes, so right now the load lock has gone to atmosphere, and I'm ready to load the sample inside the chamber. So let's do that. Let's open the chamber and let's see where we are going to actually have like to place the wafer holder. One important thing to make sure before we actually put the wafer holder is that these two discs that one can see here have their notches aligned between the two of them. So in case they are not, then I make sure to put them aligned like these, like you can see here. And so if we now go back to retrieve our sample, so here I have my sample. Once again I turn it over and I check that these three notches, both in the screen and in the sample holder, they are aligned. And then once I do that, I can go over to the lock log and load the sample. So I need to make sure that this part of the holder here is inserted where there are the two notches on the two wafer discs. And then like once I do insert it, then I need to turn the sample holder clockwise slightly. And if everything like has gone well, the notch in the second disc, the one that is behind, will be hooked to the sample holder. And so the sample holder will be in place and it won't fall. It's a good practice to actually check that all the three notches on which are here, and there's also like another one here on the side. It's good practice to check that all three of them are actually in place. That means that the sample holder will not fall once I close the chamber and I start the vacuum. So once I close the chamber, before I can do anything, I have to bring the load lock down to 110⁻⁶ pressure again. So I just click on load lock pump, and I hear that and I hear a noise of the pump starting to work, and also this light goes off, indicating that the lock is not to atmosphere anymore. And it will take around 10 minutes for the pressure to go from atmosphere to 10⁻⁶. And in the meanwhile, I can keep on selecting the processing. So like we said before, we clicked on Run Processes, then we clicked on Browse, and now we're clicking on selecting a recipe. Whichever metal we select, there is an initial thickness that is a default thickness that is normally used, but in case we need to change that thickness, then we just like click on the on the value of the metal thickness, and we just change it using the keyboard. Okay, so today we're actually going to deposit a thin layer of aluminum of our sample. So in order to do that, we click on Run Process here, and after we click on Run Process, this process execution window opens, and then we click on Browse to actually be able to see all the recipes that are available. So under User's Recipe, if I click on Evap, I can see all the metals that this machine can deposit, and both in a single run and also the metal that this machine can deposit in combination. Today, since this is just a training run, we're just going to deposit a layer of aluminum. So I'm going to select aluminum here, and I can see what the sub-processes of the recipe are. The first one, which is called lock process, will just bring the lock down to the base pressure. Then is actually going to start depositing aluminum at this rate, and then after the metal deposition, it's just going to vent the machine. Initially the thickness is set to 10 nanometers. I can set that to any value. Let's put, for example, 50 nanometers of aluminum today. After I am done with this deposition, the recipe will reset itself to 10 nanometers. So each time I log in and I select a recipe to run, I need to make sure that the desired that I change the desired thickness to the value that I want, or that I check that the desired default thickness in the recipe is the one I want. So once I have in this box here the value I want, then I just click OK, and in this white box I can just see the sub-processes that were listed in the recipe before. If I click on the plus, it's actually going to detail what the sub-steps in all the single sub-processes actually are. And since the machine, since normally this step here, the pump of the lock chamber to 210 to the minus 6 normally has a timeout of around 10 minutes, is actually a good practice to wait for the value of lock pressure that we can see here to reach a value that is quite closer to 210 to the minus 6, so that the recipe will not time out and that the machine will not give an error. So only once the pressure is quite close to 210 to the minus 6, I am going to click on this button, which is the execute button, and the machine will actually start the execution of the recipe. What I can do in the meanwhile, I can actually switch on the main power that I can see in this part here, in this panel here. So what I need to do, I need to turn the key to on, and you can see that this turns on this little LED light, but in order for everything to turn on, I also need to press the on button. And you can tell that the high voltage has come on by the loud noise that I can hear from the high voltage generator that is here right next to the machine. I need to make sure that I remember to turn off the high voltage and to turn off the key at the end of the run, in order not to leave the high voltage on while no one is using the machine. This display that we see here is actually a display showing the frequency of the crystal that is used in the main chamber of the machine to actually monitor the thickness that we are depositing. And the crystal needs to be periodically changed because it has an initial frequency of 6 megahertz, if I'm not mistaken, and as we deposit metal, metal will start accumulating on the crystal surface, and the oscillating frequency of the crystal will actually decrease. So once the frequency reaches around 5.5 megahertz, it means that the crystal is not reliable to monitor the thickness, and it needs to be changed. And changing of the crystal is normally done by the technical staff of the JWNC, because changing the crystal needs access to the main chamber of the pluses, which is this one here. So now that we're close to 210 to the minus 6, I can actually click execute, and if I do click execute, this executing window appears on the left hand side of the screen, and since we went and it lists all the steps that the pluses is actually going to go through. So next sub-process, which is listed on the left, which is making sure, if I extend the window here, it will make sure that this pressure here is below 510 to the minus 7, and then after it will select a crucible to be aluminum. There are 8 possible crucibles, and they're arranged in a circular holder, so that in order to change the crucibles, the machine just rotates the holder. And in this case, we're going to use aluminum. And after the selection of the crucible, the electron beam gun is going to be ramped to a value of current that has been calibrated to give a certain deposition rate for the metal that we're using, and once the rate is controlled to be at a certain value, the shutter will open and will actually start the deposition on our sample. So now that it's 9.910 to the minus 7, I can see that the step that is going through is the electron gun emission ramp. So what the pluses machine is going to do now is ramp the current from 0 ampere to 0.225 ampere, which is the value of the current that is supposed to give a rate of around 0.3 nanometer per second with this particular metal. And so here we can see the values of the current that the power supply is given the electron beam gun. Here we can see which crucible we actually selected. In this case it is aluminum. Here we can see the frequency of the crystal and the thickness and the rate. The thickness and the rate will actually reset to 0 and to the proper value only once the machine starts the proper deposition. And right now they're just left at the values that they end at the end of the previous run recipe. So right now we are about to start the deposition because the current is closer to the final value of 0.225. We are at a step that is called rate control. So now there's an optimization of the value of the current until the rate that we achieve is 0.3. At the moment, we are still not depositing on the sample because the shutter that is indicated by this here is actually closed. And we can see now actually the shutter, the sample shutter has been opened, and the deposition has started on the sample. So we can see the actual thickness that we are depositing and we can see the rate. And we can also see the rate in this graph here that has the time on the x-axis and has the deposition rate on the y-axis. And I can select through this drop-down list how big I want the window to be between 1, 5 and up to 1 hour. Let's put it like to 1 minute, and we can see that the rate is around 0.26. And also on the y-axis I can select the minimum and maximum deposition rate that I want to analyze. I can choose between 3 quantities that I can display on this graph, either like the rate, the power, which is actually the current of the electron beam gun, or the error with respect to the target rate, which is 0.3 nanometer per minute. Normally, by default, is always the rate that is shown. And when the machine is not active, I can decide to pause this graph. We can actually see the crucible of titanium as it's been evaporated. There is a window here, and normally it has a shutter. There's some perspex film, and so in order to see inside, I can actually need to open the shutter, and I can see the crucible. I can see the crucible, and I can see the metal being melted by the electron beam gun as it is being evaporated. Normally, after I checked that the crucible is working, it's always good to close the shutter, because otherwise the window is going to be coated in metal. The shutter is actually a perspex film, and it will eventually get covered in metal, and in order to advance it, I can actually rotate this knob here, which will advance the perspex film to a fresh bit of it, and so that I can keep looking at the metal being evaporated through this window. Through the lock window, it's not very clear, but I can actually see while the sample has been deposited, the holder rotating. So now we've deposited 50 nanometers of aluminum, so we're already done with the deposition. The rate went back down to 0. So after a 10 seconds wait, the machine is just going to close the valve between the load lock and the chamber, and once the valve is closed, then the venting of the load lock is going to start. This valve, whenever the load lock is vented, needs to stay always closed, because the main chamber needs to stay always at a pressure below 10 to the minus 6. So while the machine is venting, we can actually turn off the power supply by pressing this button here, and then we can turn off the key. And while the machine is venting, let's go through the rest of the buttons that we see here. As I said, this one is the emergency stop. This one should light up shortly as the load reaches atmosphere. And this one, they just indicate that the machine is under proper regime of operation, so that nothing is wrong with the machine. These ones normally don't need to be touched other than by technical staff, because they're going to shut off and on the machine. And general users, they just need to make sure that the power supply is switched off, but they leave the computer and the general machine on. So now the load lock has reached atmosphere. so I can actually retrieve my sample. The process of retrieving the sample is the same as what I did before, but in reverse. So instead of turning the sample, the holder clockwise, I turn it slightly anti-clockwise. I push it and then I turn it anti-clockwise in order to release the holder. And you can see that now, once I've done this, the holder comes easily off. You can see that now the sample holder is all gray because of the 50 nanometers of aluminum that I have deposited onto my sample. You will see it even in a clearer way once I take the clamps off, because you see that the clamps have actually acted as a mask on my sample, so you will see a different area. So like once I retrieved my sample, then I close the lids of the chamber, and what I do, I make sure that I leave the load lock pumping. So I click on load lock pump here, and you can see and hear from both the graphics here and the sound of the pump that the lock has started pumping. And once I've done that, I can actually close the process execution window. In order, I normally leave open the vacuum diagram window and the crystal monitor, and I make sure that I log out, so that here it says logged off, so that the machine is ready for other people to use. And so now I'm actually ready to take off my sample, so I'm going to bring it back to the cabinet, and again it's a similar process to what I did before, but in reverse. So I take this one off, I can put actually this back in the drawer. I hold the clamp with my tweezers and I put the screwdriver on top, and I slowly start to unscrew my clamp. And once it's loose enough, I can actually push it back. And if I want, I have two options with regards to what to do with the clamp and the screw. I can actually tighten it and leave it on the holder and then put it in the drawer like that, or, as I'm going to show with this other clamp, I can actually remove it completely and put it in the box of Plassis 2 clamps and screw. So once, which is this one. In any case, I want to make sure that whichever option I choose, I leave both the box and the sample holder nice and tidy, and I put everything back. So that's my sample. As you can see, I can see where the clamp were because there's no aluminum deposited there, and I can see that all the rest of the surface instead has been covered with aluminum. Here the clamp is actually tight, so I can put this holder away in the drawer, and I close the drawer, I retrieve my sample. I normally leave the screwdriver here, it belongs to this cabinet and for use of all the different classes users, and I make sure in general that everything is nice and tidy. and that is us